Hi, welcome back to another episode of Making a Programming Language with JavaScript. In this video, part 4b, we're going to be coding up an interpreter. All the code in this video will be in the GitHub repo that is linked below in the description. And if you're following along with the book Crafting Interpreters, the link is in the description below. Let's get started. First off, I want to show you what the interpreter test would look like. And how it would look like after it's done. So in this interpret.test.js file, we have a few tests. So the first test here is, so if we pass it a statement, like a very simple statement, 1 plus 5, our interpreter here is going to expect a binary expression, and this is because the interpreter is one step after the parser, and the parser is going to transform this 1 plus 5 into this binary expression, if you remember from the previous video. So this binary expression is going to be, the left side is going to be the literal 1, the operator is going to be the plus token, right side is the literal 5, and then if we pass it to the interpreter, it's going to spit out the number 6. So our interpreter so far, it's going to seem like a glorified calculator, and that is a necessary step right now. Later on, we'll be able to add all sorts of what you would expect in a programming language, like states and side effects and all that fancy stuff. This is a necessary step in making a programming language. And then in this group expression, 1 times this group 5 plus 3, this is the expression. It's in binary with a literal 1 as a left side, the multiplication operator, and then the right side is a grouping of this binary 5 plus 3. And this, we expect this whole thing to output the number 8. And then if we pass it a unary expression, basically this bang false, we expect this interpreter to say that it's true. And same with this unary expression in -5, we don't expect it to do any minus operations. We just expect it to output the number -5. So these are what we expect our interpreter to do. Now, please create a new file called Interpret.js in your source folder. And just as a reminder, I'm going to have the grammar for the Lox programming language on the right side here so we can refer to it while we're making this interpreter. So what do we need to code for our interpreter? Let's get the file started first. Want to import a few things that we're going to be using later on. And our class interpreter with the export here. And the main interpret function. So this interpreter has to evaluate expressions like we saw in interpret.test.js. And again, what are expressions? Expressions are literals, unary, binary, or grouping. So basically, we have to make sure that we write the code to interpret each type of expression here. So our main interpret function is going to be a try catch. We're going to try to evaluate the expression we pass in. And remember, the expression is one of these things that our parser turns into an expression object. If there's any type of error, we're going to call logs.runtimeError, which we'll call later on. So interpret basically depends on this .evaluate. We're going to use the visitor pattern, which I'll show you in a little bit. All right, and this is evaluate. Basically, it sends the expression back into the interpreter's visitor implementation. And what does that mean? I think might be good to show you example later. Now, visit literal expression. So this is a very simple example of what this visitor implementation means here. remember if we have a expression like a literal number or something like that, let's go to expression.js here that we coded before. So we have a literal. If we have a literal with a value of 5, what happens? So we it so basically if we call the expression.accept with this, that means it's going to call literal.accept, and it's going to call whatever was passing as a visitor, and it's going to call that visit literal expression. So what's passing as visitor? Well, it's basically this interpret object. So it's going to call interpreter.visit literal expression, and it's going to give you the expression's value, which is the value of the literal here. And whatever literal value it was, it's going to pass it and return it as the output of evaluate. So it could be a number, string, true, false, or nil. And that's a very simple example of how this evaluate visitor implementation works. And then unary expression. So what is that unary expression? Let's take a look at grammar here. Any expression with a minus or a bang in front of it. So that means we have to evaluate the right side first. Going to call this evaluate expression the right side. And once we have that right side, we're going to look at what the operator type is that we pass in. So if it's a bang operator, we're basically just going to find out is the right side truthy. If whatever it is, we're going to give you the opposite of that. And for the token type minus, we're going to give you the negative of that number of the right side. But the one important thing we have to check first is that is the right side a number? If it's not, then we can't put a negative in front of it because it's not a number. But if it is, then we can. And if it's not either of these two, that means we have an error here and we're going to return null. All right, so we saw this check number operand. What does that do? So basically it looks at is the type of the operand a number? If it is, we're going to continue. If it's not, we're going to throw a runtime error. And I'll show you what a runtime error will look in a bit. But basically we just say that, okay, this operand must be a number. And we're going to throw that and not continue with the rest of the program. And just for convenience sake, we're going to need another a function very similar to check number operands, but basically if we have a left and a right operand, then we want to check if both left and the right are numbers, and then we can continue. Otherwise, we're going to exit out there and throw an error. And we also saw another function here, is truthy. And that's if we have a bang operator. What does that do? Well, this is where we actually determine our language's implementation of what is true and what is false. And for the Lox language, we've decided that false and nil are false, and everything else is truthy, just for simplicity's sake. Another language where this is similar is actually in Ruby as well. False and nil are falsy, everything else is truthy. So here we'll look at the object. If the object is null, we return false. If the type of the object is Boolean, we return the Boolean of the object. Otherwise, we return true. And that's how this works. So we pass in either, and then, so this dot is truthy, returns a Boolean, and then we return the opposite of that because this is the bang operator. Next is grouping expression. So what's grouping expression? Let's take a look at our grammar again. So it's anything inside a parentheses. So that basically means that we just have to evaluate whatever the expression is, and then we'll return that. Pretty simple there. And our last one is visit binary expression. What's a binary expression again? So it's any operator with an expression on the left and an expression on the right here. And the operator, again, can be any one of these things here. So this is going to be our longest function here. Now again, we want to evaluate the left side and the right side first before we apply the operator to both of these expressions. Once we have that, we're going to look at the operator type. If it's the greater than operator, so it's if it's this one right here, we're going to check if the number operands are numbers, and if so, we basically just check is the left one greater than the right one. Same with the greater equal sign. And with the less than sign, we want to check if the left number is smaller than the right number. And similar with less than or equals. And for a bang equal, we basically want to check if they are equal. And if they are, then we return, or not, we return the opposite of that result, which is a Boolean. Same with equal, except we basically just check if the left and the right are equal. For the minus operand, want to do the left side minus the right side. And for the plus token, so plus is a bit different. If you remember in the previous video, we said that the plus is overloaded because it can handle both numbers and strings. But the important part is that if we're handling numbers, both the left side and the right side have to be numbers, and then we can add them. If we're handling strings, both the left and the right side have to be strings before we can add the strings together. And for the plus sign, if this does not match, then we throw an error because the operands must be either two numbers or two strings. And then I think some final tokens we want to deal with: the slash, which is the division operator, and the star, which is the multiplication operator. And you can see for all of these operators that deal with numbers, we have this check number operands just to make sure that what we're the left and the right operands we're dealing with are numbers before we actually pass it to the operation, just so that we don't run into runtime errors. And again, if none of these match, then we throw null because it's unreachable. And finally, we want to code up our is_equal function. So we're looking at if A is B, and if A is null and B is null, then we return true. If A is null, we're going to return false. And then we're going to use JavaScript's strict equality comparison without type conversion. So that's going to be the 3 equal sign here, because we don't want to do any implicit comparisons. And that's it for our interpreter. Next, we want to look at what runtime error is. In your source directory, create a file called RuntimeError.js. And in here, it's going to be a simple class that extends error, and it's going to take on a token and a message. Very simple. If you look at here, basically, let's find an instance of runtime error. Yeah, so whenever we throw runtime error, we're passing the operator and then a message here. And that's basically what our runtime error does. So finally, what we want to do is look at Lox.js and hook up our interpreter into Lox. All right, in our Lox file, we're going to do a few things here. So we want to call, we want to hook up our interpreter into Lox like this. And in our constructor, we're going to initialize our had runtime error to false. And then under run file, we want to see if it had an error or had a runtime error, and we're just going to exit out of that. And then in the run method, which is the main method here, you can see that the parser will finish parsing and pass back an expression. And then we're going to pass the expression into the interpret.interpret function right here. And finally, we want runtime error function, which basically console logs the error and sets the variable does not have runtime error to true. And I believe that's it. Yes. Oh, and one more thing. We do want to import our parser here. So let's do that. Also import our interpreter into this file. And that's it. Let's try our interpreter and see how it works. So we'll call node source/main.js in the repo and some basic functions 1 plus 3. There we go, turns 4 out. Let's try a grouping here. Let's do 6 divided by, let's say like 3 minus 2. There we go, turns 6 expected. Let's try unary expression. Bang 8, what will that return? False, because everything other than false and nil are true. So 8 returns true, the bang of that is false. Yep, that's what we expected. So it looks like it's working quite well. Thanks for watching this video. If you do like it, please hit the like and subscribe to get notified for the next video. In the next video, we're going to be looking at adding state to our interpreter. So we're going to be able to do some pretty cool things like keeping track of variables and then doing some side effects and things like that. Thanks.